Good morning. Welcome to Current Chem World. In this video, we'll see what are cycloalkanes and their stabilities, how Baeyer strain theory is used to explain the stability of cycloalkanes. Okay, what are cycloalkanes? The general formula of cycloalkane is CnH2n or CH2n times. For example, cyclopropane. Okay. These are the 2D two-dimensional representation of cycloalkanes. Cyclopropane, which is very unstable, cyclobutane, cyclopentane, cyclohexane. Cycloheptane, octane, they do not exist. Okay, why? How Bayer's strain theory is used to explain the non-existence and stability of cycloalkanes. Baeyer in 1885 proposed a theory to explain the stability and the non-existence of certain cycloalkanes having lower ring sizes or higher ring sizes. Okay. More specifically, only 5 and 6 member cycloalkane rings were known. That is cyclopentane and cyclohexane are more stable. So they are abundant. Whereas cyclopropane, cyclobutane are less stable and they are not produced, they are not formed. And also cycloheptane, cyclooctane, they do not exist. Baeyer theorized that these could not be prepared because their bond angles would necessarily deviate from the preferred sp3 bond angle of 109.5 degrees. For sp3 hybridized, each carbon atom is sp3 hybridized in cycloalkane or alkane. The bond angle is 109.5 degree. Okay. In cycloalkanes, for example, cyclobutane, cyclopropane, their bond angles would deviate from this bond angle. This deviation from the sp3 bond angle would cause angle strain, that is called Baeyer angle strain, that the rings would be too unstable, would not be stable to exist. He proposed the bond angle strain in various cycloalkanes. For example, cyclopropane, the bond angle is 60 degree. What is the angle strain? 109.5 minus 60, that is 49 degree approximately. So this is a large deviation from the original 109.5. So cyclopropane is least stable. Let us see next cyclobutane. In cyclobutane, the bond angle is 90 degree. How much the deviation? 109.5 minus 90 degree. Okay, 90 degree, that is 19 degree. In this case, the angle strain is less compared to cyclopropane. Okay, it is fairly stable now compared to cyclopropane, but still there is a deviation, angle strain. In the case of cyclopentane, okay, the bond angle is 108 degree, that is 109 minus 108 equal to 1 degree. There is much less deviation, there is much less angle strain. So cyclopentane is most stable. It exists, it can be easily prepared. Let us see cyclohexane. In cyclohexane, the bond angle between carbon is 120 degree. What is the deviation? 109 minus 120 degree, that is minus 11 degree. Okay. Based on the above table angle strain, he concluded that cyclopropane would be the most strained, followed by cyclobutane. That is, the relative stabilities of cycloalkanes are shown here. Okay. Cyclopentane is the most stable, cyclopropane is the least stable. The higher cycloalkanes are not formed because of angle strain. They do not exist, they cannot be prepared. Cyclopentane would be strain free, while cyclohexane would also show a substantial amount of strain energy, that is minus 11 degree. Rings larger than cyclohexane would be highly strained, so they are not existing. Thank you for watching. Please share and subscribe. Thank you again.